3 is one of your favorite math words.
Woo!
Graphing.
Yes. Woo!
We're going to graph radical functions. So we are graphing functions that have radicals in them. We are specifically focusing on square roots and cube roots. Okay, so I'm going to start by, okay, let's look at what does a square root graph look like? How can we graph a square root graph? We're going to talk about a cube root graph. And then we'll get into all of the different, we're going to review our translations and all the different ways we can work with them to graph them. So, y equals square root of x. Basic square root graph. This is going to be a good one to know. Honestly, probably graphed a square root graph back in Algebra 1, but I can't guarantee that.
Oh.
Okay? And again, I know 2 years ago for most of you, not expecting you to remember it. Okay? If I don't know what a graph looks like, I'm going to encourage you to think XY chart, right? Thoughts of numbers you want to put in on this XY chart?
1, 2.
I like 1.
0.
I like 0.
2. 4. 4.
I like 4.
8. 16. 32. 9. 10.
I like 9.
Oh, we said perfect square.
What kind of numbers did I pick out of your numbers you were throwing at me?
Square.
Perfect squares, yes. Okay. Now, so my suggestion when you're trying to graph a square root function is that normally I would love 0, 1, 2, wouldn't I? But I didn't like 2 this time because what is the square root of 2?
It's like point.
It's a decimal, right? It's 1.4 something. I don't want to graph a decimal if I don't have to. So when we talk about what's our basic XY chart for a square root function, notice 0, 1, 4, 9 are all numbers I can take the square roots of. If I put 0 in for x, what's the square root of 0?
0.
0. If I put 1 in for x, what's the square root of 1?
1.
If I put 4 in for x, what's the square root of 4?
2.
2. And if I put 9 in for x, what's the square root of 9?
3.
3. Now, could you go bigger if you wanted to or needed to?
Yep.
Yeah. What is the next number I would put in my XY chart?
16.
16, because that's my next perfect square, isn't it?
Yep.
I saw in the process of this, some of you pulled your blue papers out. Any of those numbers on the blue paper would be good numbers to put in here, depending on how big you want to go. I stopped at 9 because my graph isn't set up for 16. No one threw any negatives out at me.
Is that a problem?
I don't know. Is it a problem?
Oh, no. Could be. If your x was negative, I'd do that. No.
Well, can we take the square root of -1?
No.
Can we take the square root of a negative number?
No.
No. So is there a reason I avoided negatives on my XY chart?
Yep.
There is. Okay, so go ahead and graph this. You have a point at 0, 0. 1, 1, right 1, up 1. 4, 2, right 4, up 2. 9, 3, right 9, up 3. Okay. It does extend past this point. As you connect your dots, though, let me stress that this graph is starting at 0, 0. You do not extend the other way through 0, 0. My graph starts at 0, 0. And what does this look like?
It looks like a U. Or like
Okay.
Like
not a full U, but maybe half of a U? How about half of a parabola?
Right.
Okay. We'll talk, I think it's lesson 5, 4, 5, 6, we talk about inverse functions. And the square root of x is the inverse of x squared. So this is legitimately half of a parabola. Now, I also have to throw in the fun domain and range words here. Okay. These are words we've got to work with and become familiar with. What do I mean when I say domain?
Left, right.
Okay. How far left and right my graph goes? We're talking in terms of x's here, yes?
Yep.
How far left does my graph go?
0, 0.
Okay, it goes to the x value of 0. How far right does my graph go? Infinity. So one way to write this is 0 to infinity. And if you remember interval notation, 0 would have a
bracket,
because 0 is included. Infinity always uses a parenthesis. You have some domain and range questions in homework. If I recall, they're more multiple choice, and they give them an interval notation. Okay? I would not be opposed, I don't know if anyone said this, but x greater than or equal to 0, that would be an equality form. My opinion is be familiar with both, but from what I remember I saw in the homework, you're going to see any interval notation. Okay? Now, what about range? Domain is left or right, and my x's. So range is up and down, and my y's. So how low does my graph go? The lowest y value here is 0. And we talked, we don't go into the negatives with this, so it's not going to go any lower. How high does this graph go? Currently 3, but what about if we keep going? Is it going to infinitely go up?
Yeah.
It is, very slowly. Okay? It's going to slowly go up, but it would continue going up. And so my range is also 0 to infinity. Or, if you wanted to use inequalities, you could say y greater than or equal to 0. Again, interval notation is what I was seeing in the homework, though. And good news, I don't remember you having to write any interval notation, unless I didn't practice with those problems. Okay? Okay, so that's your square root graph. Anytime we graph a square root graph, we're graphing that half of a parabola, and it's going to look something like that. Now, it might stretch or shrink. It might translate left to right or up or down. It could reflect. But this is the basic shape of the graph. Okay. The other graph I want to talk about, and I'm going to introduce them both to you so you have the information in your notes, a cube root graph. Okay, so cube root of x. Again, if we don't know what the graph looks like, I'm going to suggest try an XY chart. Some x's you might want to throw in here.
0.
I like 0.
Why move -8? Oh yeah, because it's 3. Yeah.
Oh yeah.
Do that.
-3.
Oh. And then +1 and +8. Oh.
Okay, so first of all, notice these numbers are perfect cubes. Okay, these are numbers I can take the cube root of, and there's negatives thrown in here. Can we take the cube root of negatives?
Yeah.
Yes, because when you multiply 3 negatives, 3 negatives multiply to be a negative. So it does work. So if I start here in the middle, the cube root of 0 is 0. The cube root of 1 is 1. So 0 and 1 would be on any of these graphs. Square root, cube root, fourth root, anything. What's the cube root of 8? 2. I didn't go to the next cube root because I didn't want to graph 27. I don't know if you guys really want to graph 27 either.
Yeah.
Tried to keep it nice. Now, what's the cube root of a negative 1? And that is negative 1. Because negative 1 times negative 1 is positive 1. Times another negative 1 is negative 1. 3 negatives multiplied to be a negative. And what's the cube root of negative 8 then? Negative 2. So that's the basics. When I ask you to graph a cube root graph, I'm going to say, okay, start with this chart and go from there. So let's graph this. Left 8, down 2. Left 1, down 1. 0, 0. Right 1, up 1. Right 8, up 2. No longer half of a parabola, is it?
So,
There we go. If you guys can think about y equals x cubed and what that looks like, y equals x cubed is a graph that starts low, angles up through 0, and goes up high, right? Well, the cube root of x is the inverse of it, so it's sideways here. Okay? So you could also, in a way, kind of think of this, not exactly, but it's almost like two halves of a parabola going different ways. Not exactly, though. The numbers don't work out exactly. Okay, so that's your cube root graph. That's the other graph that we're going to be moving around today. Thoughts on the domain here? Yeah, how far left and right does my graph go? It's going infinitely, right? So my domain is negative infinity to positive infinity. Remember to use parentheses with your infinities. If I put that, we don't really have a good inequality, but it's also the same as saying all real numbers. Okay, that would also be equivalent, is to say all real numbers. What about range? Now we're talking y's.
Same thing.
How low does it go?
Same thing.
How high does it go? Yeah. It's not going to move very fast, but is it going to keep going lower? And is it going to keep going higher?
Yeah.
And it is. So my range is also negative infinity to positive infinity, or you can use the phrase all real numbers. Now, here's a nice thing. All cube root graphs will always have the same domain and range. It doesn't matter where I move this graph, how I flip this graph. It's always going to go infinitely left, infinitely right, infinitely up, infinitely down. So your domain and range for cube root graphs will always be the same. Now, for square root graphs, it will change. It can change based on where your graph is, so beware there. And we'll practice a little bit as we get going in this lesson more. Okay. You all have this written down, yes? Because this is what you're going to want to reference as you go through homework and as we go through more notes. So, two sets of information here in the middle. First of all, a radical function is a function of the form f of x equals a times the nth root of x minus h plus k. That's the form for everything we're doing. Okay? N is standing for your root there. But besides that, if you think about what we did first semester, a number that multiplies out front, is your stretch or compression. So we're back to talking about vertical stretch and compression. H, what's the number under the radical with the x do? It tells our graph how far left or right to move, yes? And so here it says horizontal translation, or if you struggle with horizontal, it's your left and right movement. Okay? And then K determines your vertical translation. So remember, the number at the end, away from the x, is going to be vertical, so that's going to take us up and down. Now, I threw this chart on here. Does this look familiar? I think we saw it in chapter 1. I think we saw it in chapter 2. Maybe even chapter 3. We've used it in every chapter, I think, so far. Okay. I did tweak things a little bit. Instead of these being C's, I changed them to match the H and K's. But there's your reference. Remember when we go up or down? It's direction of the sign. What about when we go left or right? Remember, you end up going opposite the sign, right? So beware there. What do negatives do? Negatives are going to reflect a graph. You're going to see some negatives today. Okay. A number out front is a stretch or compression, vertical. Now, if you see a number under the square root with the x, which you might see that come up in a homework question, that's going to be a horizontal stretch or compression. So just kind of beware of that. Okay, you have this chart in front of you. Again, make use of this information because we're ready to graph. We're going to practice graphing this. Graph each function using transformations, identify domain and range. So here's what I'm going to say. F of x equals the square root of x minus 5.
Well,
how can I graph this?
Right. Okay. How do you graph it, Landon?
Hey Josh, how do you graph it?
What's that 5 doing?
Landon.
It goes right 5.
Okay. That 5, because it's a minus 5 under the radical, I'm going to take my graph and move it
Right.
right 5.
Okay.
Now, as we think about that, kind of a silly question, but what am I moving right 5?
Get a point. I don't know.
Your vertex. Axis of
Okay.
symmetry.
And which graph are we graphing here?
X.
This is the square root of x, yes?
Get
So realize this is square root of x. And so we're going to use the basic square root of x graph from above and then move it 5. So if I'm not going to write down the whole one, but what were my values from before? It was 0, 0, 1, 1, 4, 2, and 9, 3, correct? So we're going to take these values and then we're going to move these values 5 to the right. That's my suggestion on how you graph this. Kind of like when we moved parabolas around, or we moved absolute value v's around. Now, it's up to you how you do this, but if you want to put the original dots on, you can. 0, 0, 1, 1, 4, 2, 9, 3. That's a personal choice. You may not want to put those original dots on, but if you put those original dots on, that's fine. And then take each of those dots and move it where?
Right 5.
Right 5. I'm going to find a different color here. So my dot that was at 0, 0 is now going to be?
5, right? Or 0? Yeah.
5, 0, yes. My dot that was at 1, 1 is now going to be at 6, 1. My dot that was at 4, 2, move it 5 right, and it's going to be at 9, 2. Didn't plan this very well, but that's all right. My dot that was at 9, 3
Oh.
is going to be at 5 right, so it's going to be at 14, 3.
You're basically just moving the whole thing right.
Yep.
I like it. All right.
Yeah, so I took us the route of, okay, let's put the original dots on there, let's move each point 5 right. The other option is, could you have just moved the dot at 0, 0?
Yeah.
Moved it 5 right, and then from that point go over 1 up 1, over 4 up 2, over 9 up 3.
Yeah.
Kind of like what we did with parabolas. Okay, so it's kind of a pick and choose thing. Now, when I graph these, obviously I'm looking for accurate points. When you see these in homework, it's going to be more of a multiple choice thing. So picking the graph that's facing the right way and move the correct way is going to be your big thing. Okay? Questions on A? Aaron, behave. Okay, B. Thoughts on B? There's what? There's a negative. What's that negative going to tell me to do?
Reflect.
Reflect. Okay, so that negative, I'm going to put it up here, is a reflect. And specifically, it's reflect across the, which one? X-axis. And I know it's reflect across the x-axis because that negative is out front of the radical. So this is going to be reflect across x-axis. Okay? What about the 4?
Left 4.
Well, is it in the radical?
The 4 is not in the radical.
Range on the left one.
Boom! Because I saw that it wasn't this one.
We need to go back and talk about domain and range. Hold on. Let's finish this problem, then we'll go back and talk domain and range.
What?
I forgot my own directions of domain and range. And I'm doing that because you're going to see it in homework. So let's graph this one, then we'll do domain and range on both of these.
Oh, it's not in the radical.
That 4 is not in the radical.
That's what I thought.
So what's that mean about that 4?
That means that you stay forward to the right.
About up 4.
All right.
Okay? It's going to go up 4 because a number that's not with the x is not in the radical. It's going to take it up or down. Sound a little bit familiar?
Yes.
There was kind of some talk about it, but then not everyone was on board quite there. So, now, here's my question. What is the XY chart we're starting with here?
Cubed.
Yeah, this is the cube root of x, yes? So we're going to start with that chart that was -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Okay? And then we're going to take those values there. And we're going to reflect them first. You're going to have to reflect across the x-axis. And then, after reflect across the x-axis, then we will take those points and we will move them, what did I say? Up 4. Okay. So, how many points do you want on your screen or on your graph? Okay. Here's the deal. If I lightly put what my normal points are, left 8 down 2, left 1 down 1, 0, 0, right 1 up 1, right 8 up 2. Those are my initial points, yes? You might choose not to put those. You kind of hang on and see what's happening. What's the first thing I said we needed to do? We need to reflect. When we say reflect across the x-axis, what's going to happen?
Flip, right?
It's going to flip, yes? Anything below the x-axis is now going to be above. Anything above the x-axis is going to be below. And anything that was on the x-axis stays. So I'm going to take this point and flip it up. So -8, -2, and -1, they're flipping up. 0, 0 just gets to hang out where it is. 1, 1 flips down. And 8, 2 flips down. So right there in green are my reflected points. Okay? So basically I've taken this graph and it looks upside down. Then what do I do with those green points?
Then move them up 4.
Then move them up 4. And so I'm going to change to orange. So I'm going to take my green points, I'm going to move them up 4. Up 4. Up 4. 0, 0 is now at 0, 4. Up 4. And up 4. Orange points are going to be my final answer there. Okay. Are we trying to figure out the coloring situation? If you're wanting to color code? Okay. So, I would not connect any dots until you get to your final graph. Otherwise, it really looks messy, doesn't it? In homework, in Sava's homework, you're just going to have to judge, okay, which way is it supposed to look? Did it move appropriately? Those type of questions there. Okay. Totally overlooked my own domain and range questions. You will see some with domain and range, which is why we need to practice it. Good news is you now get to start with the easier domain and range, because I'm going to start on the graph we just did. Okay, on example B, what's the domain here? Yeah, on a cubic or a cube root, my graph goes infinitely left, infinitely right. So negative infinity to positive infinity. What about the range?
Infinity to negative.
Goes infinitely down, infinitely up. Doesn't move as fast, but it does do that. So my range is negative infinity to positive infinity. Okay. Aaron, you have a confused look on your
Well,
face.
I just thought that because it'd be flipped. But I guess not.
What did you think it was supposed to be?
No.
Okay. Because I thought you said what I wrote, which is why I'm confused now.
No, I got it.
Oh, okay. And here's what I'll say. With domain and range, you always go smaller numbers to bigger numbers. Always, always, always. So negative infinities always can always begin something. Positive infinities can always end something, but you can't flip them. Smallest to lowest. Okay. Now we got to go back and talk about A. You can look at your equation. You can look at your graph. But domain. How far left is my graph going? How far right is it going? So how far left did this graph go?
Never mind, I'm wrong.
2, 5. It went to.
It goes over to 5 now, right? Normally it goes to 0 and to the right. But now I move that 0 point over to 5. So now my graph starts at 5. 5 to what? Infinity. Infinities always use parentheses. 5 is going to use a bracket. Because is 5 included here? Yes, it is included. So 5 to infinity there. Okay, range. Okay. How low does this graph go? What's my smallest y value? 0. My graph never goes below the x-axis, does it? It never goes below this 0.50, and the 0.50 has a y value of 0. So this is 0. How high does my graph go? It goes up infinitely. So 0 to infinity. And 0 again has a bracket. Okay. Did I skip over anything else?
No.
I think that's it.
Okay. And I will say, guys, as you get accustomed to these XY charts, did I necessarily have to write these XY charts down here?
No.
No. I'm just trying to help you guys have information in your notes. It's going to be helpful in the future. But you could have honestly just gone straight to your chart, looked at, or to your graph, looked at your chart up above, and been fine. Okay, on the back side, we got a couple more graphs to do, don't we?
That's okay.
Okay, now, I will say, hopefully these graphs look a little bit more difficult, because they are a little bit more difficult here. Okay, same directions, graph using the transformations, identify domain and range. So, let's start by talking about what you see on example C.
I see code running.
You got a vertical thing of -2. Vertical stretch.
Reflected across the x-axis.
Oh, reflect across the x-axis.
And-
Vertical stretch.
Okay, so here's the deal, guys. Negative and 2. Remember, they have to separate. We talked about this at the time. The negative indicates a reflection, like what we just did. The 2 is a vertical stretch. Okay? And then, let's see. I'm going to put this up here. So the 2 is a reflection, or excuse me. The negative is a reflection. The 2 is a vertical stretch. By the way, I should have asked this sooner. What type of reflection? X or Y axis? It's out front, right? If it's directly on the X, we can talk Y. But since it's out front, this is going to be reflection across the X-axis. What else do we have here?
Well, you gotta go left 3 and up 5.
Okay, so a plus 3 in the radical is left or right. When it's in the radical, it's left or right. Remember, you go opposite the sign, so that is a left 3. The plus 5 at the end is up or down. Direction of the sign, so that is an up 5. Now, with that in mind, okay, we add a new piece here that we have to work a little bit harder to figure out, and that is the stretch. Okay, my recommendation is that we begin with the vertical stretch. Vertical. Which values are vertical? Are those X's or Y's?
Wow.
Okay. Vertical values are my Y values. So when we, come on guys, when we're talking about vertically stretching something, we are multiplying the Y values by 2. Now, if we want, we can also go ahead and do the reflection here. Because I want to have something down paper, what I'm going to do, which XY chart do I need to use here? This is the square root of X, yes?
Yep.
So I'm going to write down my XY chart for square root of X, which was 0, 0, 1, 1, 4, 2, and 9, 3.
Yes.
But I'm not going to graph those points because then my graph's going to get really messy. But we're going to, you want me to go ahead and do the stretch and the reflection at the same time?
Yep.
Yeah,
Yes, I
that's
do.
Yeah.
Okay, so in order to do the stretch and the reflection at the same time, I can take each of my Y values and multiply by -2. If we just multiply by 2, it's just doing the stretch. If we multiply by -2, it's going to take care of the reflection and the stretch. So I'm going to write out what those values are going to be. Notice my X values aren't changing. It's a vertical stretch. It does not touch the X values. So 0 times -2 is 0. 1 times -2?
-1. -2.
-2. 2 times -2?
-4.
-4. 3 times -2?
-6.
-6. So here's the deal. We're going to take your original X's and your new Y's, and we're going to graph this. So I'm going to graph, still 0, 0. But now it's going to be, instead of 1, 1, 1, -2. So right 1, down 2. Instead of 4, 2, I'm going to go right 4, down 4. And instead of right 9, up 3, it's going to be right 9, down 6. Now, what is that the graph of right now? That is that is the reflection because it's upside down, and it is the vertical stretch. What else do I have to do with that? We now have to, then you're going to take that graph and move it where? Yep. Left 3, up 5. So I'm going to take each of my green points and move them left 3, up 5. 1, 2, 3. 1, 2, 3, 4, 5. Do that with each of your dots.
Is that the end one? Is that the last one?
Yes.
Okay.
Okay. So my blue points are my final answer. I took each of those points and moved them, excuse me, left 3, up 5. This blue graph is that square root graph, flipped upside down, stretched, so each value goes 2 farther in terms of y, and then moved left 3, up 5. Okay. The one thing I haven't talked about is domain and range.
I don't know even know.
Domain. How far left does my final graph go? Right there at -3. How far right does it go? All the way to Miss Minnickstrom, yes?
Mhm.
So that makes my domain -3, so from that vertex, so to speak, to infinity. Range, this is a tricky one.
It'd be 5, right?
How low does my graph go?
Negative.
It's going infinitely low, -infinity. How high does it go?
5.
And that is at 5, yes. And so my range is -infinity to 5. And I'm not sure why I just put parentheses here. That should have been a bracket on the -3. Okay, guys, we'll finish notes tomorrow. I didn't even have to draw it out. We didn't get through them.